but there were a lot of unexpected things that we didn't anticipate. And a lot of that has to do with the fact that these graph databases are amazing because there's virtually no penalty for doing joins.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
All right. Welcome, everyone. I want to thank Dan McCreary here today, our guest, our first Applied AI podcast. And Dan and I have known each other for many, many years. Both sort of been working in the local Twin Cities tech community and coming at it from different angles, obviously, but all, sort of under the same sort of common vibe. And I appreciate Dan taking his time here and sort of sharing his experiences with regards to artificial intelligence. Dan, if you wanted to sort of start, maybe talk about your background, sort of what you're doing these days, and maybe sort of how you got to this point.
Happy to. So right now I'm working within Optum. Optum is a division of United Health Group. We do a lot of the IT division. United Health Group is a very large company, almost 335,000 employees and 32,000 IT employees. And I work in a very small area called the Advanced Technology Collaborative. And UHG is a very distributed group. It's not like Amazon or Apple that has very centralized control. It's very distributed. We buy about 40 companies a year, and we buy them often just for their data. And the job of the Advanced Technology Collaborative is to scan the horizon for technologies that are going to be relevant 2 to 5 years out and help our business units decide which ones are relevant. The bulk of a lot of our work is directly related to AI. And the rest is almost indirectly related in some ways, getting more data to power our AI engines. And what we're really focusing on now is getting more data, more connected data, and then allow our data scientists, we have 3,200 people with the title of data scientist, faster access to high quality connected data to build machine learning models all over the organization for every possible thing related to healthcare, in the clinics, in claims, in providers, in networks, or contracts. We're trying to be driven by predictive analytics and machine learning.
Awesome. Very cool. So how would you define AI? I mean, AI is a pretty broad scoping term in the context of what you guys are doing, and maybe just your own personal context, if you're to sort of explain it to a layman or laywoman.
Yeah. Layperson, yes.
Layperson, there you go.
Yeah, it is a very broad thing. And I think what's important about the definition of AI is it changes every month. It's something that's always changing based on what people used to think was difficult is now commonplace. And things that are just beyond what we can comprehend are considered AI. So my best example is Alexa. 10 years ago, we couldn't just talk to our home audio system and do various discussions and get the answers back and have it almost be an interactive system. I was just checking to make sure my Alexa was turned off.
I've had that happen, right?
Talk about
always listening.
Yes, exactly. But it's one of these things where every year, what you used to think was AI 5 years ago is now just part of everyday an appliance. It's part of our environment, and there's a lot of things happening behind the scenes. What's important for me about the definition is that a lot of people that are new to the field are only associating AI with machine learning. And I think that's a big mistake. Machine learning, and specifically deep neural networks, have really dominated the industry and a lot of the new developments. But it's not everything. I'd say 80% of the innovation has really come from there, but there's still about 20% of areas that are coming from symbolic reasoning and inference and connecting data sources together and then being able to traverse that in a lot of the predictive algorithms that we see in knowledge graphs. I think those are very complementary to things that are in AI. So it's a changing field all the time.
Nice. Yeah, very good. And I think we'll talk a little bit about the knowledge graphs and stuff like that pretty soon here. But one of the things that you and I were sort of kind of going back and forth before we had this podcast was, you had talked about Optum kind of transitioning from a batch mindset to maybe real-time point of care clinical decision support.
Yeah.
Is there, I guess in one case, maybe you could sort of elaborate a little bit more on this real time aspect. And do you think AI needs to be real time to really be AI? That's a little bit of a side question, but yeah, I'd be curious to see what you think.
Yeah, that's really important. So, right now in healthcare, in the United States, we're dominated by this thing called fee for services. And fee for services is every time you go and have a procedure done, maybe an eye exam, a health checkup procedure, every time you go to a hospital, they code everything that happens and they get reimbursed for the number of procedures they do. And the more procedures they do, the more they get reimbursed. So there's no incentive systems in place to limit the number of procedures that are maybe borderline. Maybe they're not really necessarily. If they're clearly not necessary, that's fraud, but there's a huge amount of edge cases. My wife had a spot of indigestion a while ago, and she went in and they did $13,000 of highly invasive tests just to make sure it wasn't heart related problem.
Wow.
And if they really would have looked at the data and her Fitbit data and all those, so she had a very, very healthy heart.
Mm,
There was no real reason to do $13,000 to test. And that's a good example of how the old way is doing. Now, what we're trying to do is move to this thing vertically integrated, where Optum doesn't just do the claims for companies. We actually own the clinics. We pay the doctors and the nurses as our staff, they're full time employees, just like Mayo Clinic has full time doctors, and that we also provide the insurance, which means that we are highly incentive to give high quality care and yet also minimize unnecessary procedures.
mm,
And
gotcha.
that the studies in general, those are called ACOs, accountable care organizations. The general studies at ACOs are about 30% less than fee for services. And so what we're trying to do is transition that. And that means we have to buy clinics. But what's important about that is when a physician or a physician assistant or nurse makes a judgment about what tests are necessary, what drugs are required, they'd like to be able to use data. And the point is, you can't run a batch job overnight and say, look, according to your symptoms and your clinical history and your entire genome and all your background, we're going to come up with the right drug for you tomorrow, right? That just doesn't fly, right? It's when the people are using that electronic medical record system and they say, well, we're going to give you a prescription for an antibiotic. And what they might do is they might have a deal with the local drug company and they'll give you a very expensive drug. Or what if we could tap into the entire equally effective settings and give you the least expensive drug? The point is, we have to do that. We have about 100 milliseconds to make sure there's no lag in that drop down
Huh.
list. 100
Wow.
milliseconds. And that's what we call real time clinical decision support. Now, we're not trying to take over the job of a physician or nurse. What we're doing is give them a ranked list of options and the pricing associated with that to help them make better decisions and then also explain it, right? So we can't just make a recommendation. Our AI has to explain why. And the reason why is that we use real world evidence. Real world evidence is a term that we're using over and over to say, gee, we have 200 million people in our database, and we've extracted the 20,000 that are most similar to you. And we've looked at their profiles of which drugs are most effective. And here are the ones that we are recommending. And then we let them choose and make those decisions. But there's a lot of decision and data behind all of that information. So it's going to be where we can't just think about it overnight and do analysis. We need to do it in about 100 milliseconds. And that means that our infrastructure has to be much more robust, much richer, and be able to do comparison, what we call similarity calculations in real time.
Gotcha. Wow. Yeah, that's fascinating. And so, how long have you been working in healthcare? Because there's a lot of terminologies I'm sure you've picked up along the way, and acronyms and all that type of stuff. So, it's,
Yeah, and if I dive into acronyms without explaining them, well, just stop me and I'll try to define them. But I've been on and off in healthcare about 15 years, and then the last 7 years really focused in on large scalable data strategies for Optum, and then in the last 2 years really shifting towards the clinical. And I just tell you, clinical is an incredibly deep field. So many complicated terminologies and medical systems and things, and it just takes a long time to come up to speed. But it's something that I'm really lucky that I can work with a lot of people within Optum that are, have to have 20 years experience building clinical decision support systems. And the role of AI and natural language processing is just going to be incredible as far as helping our clinics and our physicians make really good data-driven recommendations in the future.
Yeah, yeah, for sure. So when you need to make this decision in 100 milliseconds, obviously there's a ton of data that you are going to be trying to pull in and analyze, and maybe this is where the knowledge graph and all that stuff sort of comes into play. You want to explain a little bit how that works?
Yeah, absolutely. So let's talk about the old way that we used to hold clinical data. In ancient times, we
Hmm.
used stone tablets, right? And we carved our records in rows and columns in the Sumerian tablets. And those rows were Ashuk owes Alok 50 bushels of grain, right? And we always stored those data in rows and columns. And for the last 5,000 years, we have been doing rows and column oriented data. That means going back to punch cards and punch cards going into flat file systems and flat files being run by COBOL and copybooks and things like that. And then somebody said, hey, what if we actually created these IDs in these columns and matched them together whenever we run a query and come up with a new idea? And that had this idea of a join, where every time we do a query, we compare all of the data sets and all of those tables and tried to figure it out. And every time we did the query. But that worked as long as you had a few tens or hundreds of thousands of records. Once you start to get the millions of records, joining data gets really expensive. And what's odd about clinical systems is that there's so many relationships between you and your conditions, your allergies, your drugs, your symptoms, your prescriptions, your providers. Just the list of relationships goes on and on and on. And what happened is people have found that they just couldn't bring up that data quickly enough by doing
Hmm.
joins. So around 2010, the people at Neo4j built the first what's called index-free adjacency graph system. And they start out very small and modestly in a Java jar file. You just load it into your thing, and it would use memory pointers to hop through relationships. The fastest operations that computers can do are pointer hops. And those systems were wonderful, but they had this unfortunate problem that once you had more pointers that would fit in your RAM, the systems would kind of fall over and die in their query performance.
Sure, sure.
So it
Because it was all
wasn't
loaded in memory at that
right,
time,
right.
right?
Those pointers had to be loaded in memory. If they weren't in memory, then you'd swap out to disk and your query performance would just drop to the floor. So they worked really well in a lot of pilots and just failed when we tried to get the hundreds of millions of patients in there. But about 2 years ago, this company called TigerGraph really started to develop distributed graphs. And they were the first company that really completely cleaned the slate, started from scratch, and built a distributed graph systems. And they're not the only ones in the market, but they're the ones that have the most robust security models. And in healthcare, we need very, very robust access control lists. So we've been really going towards these distributed graph systems. And what's interesting is everything we've learned in the Hadoop world. I
Uh,
don't know if you ever did Hadoop stuff, they had this thing called map and reduce.
hmm.
The map is where you go and grab all the data that's necessary on all the distributed nodes. You do the calculations on all those nodes, and then you reduce the results and collect them all together. And now what TigerGraph and other companies are doing is they're building that map reduce into distributed graph. So if I say, show me, you have a 200 million patients, show me the 10,000 that have this condition, each of them will go through their distributed graphs, grab the subset, and then bring it back really quickly. And that's how we'll be able to run these reports in such incredible. The name for that is called HTAP, hybrid transaction and analytical processing,
Hmm.
because we're getting the speed of the traditional analytics, but we're doing it with in-memory pointers in a distributed and scalable way. As we add more patients, as we buy more companies, we just add nodes to the clusters, and we don't have to redesign our systems from scratch. So that's really been a big transformation for us at scale, is going with distributed knowledge graphs.
Neat. Very, very cool. Yeah, I think some of Google's early stuff was MapReduce. I mean, in fact, I think they were some of the pioneers in that space. Is that
Absolutely. Yeah. And just to give Google all the credit that they deserve, they also were the first to really do knowledge graphs at scale. In 2012, they wrote a paper called Things Not Strings, where they were allowing you to search the semantic meaning because you might type in a keyword. That keyword is looked up in a graph. It looks all of its aliases and synonyms and all this other stuff, and it finds all the documents related to the thing you're looking for, not just a keyword match. And they showed that those graphs scale back in 2012. So this year we are 8 years later, and most companies have not yet integrated those technologies into their production systems. But Google really proved that these things not only are flexible, great at storing knowledge, but also scale. And I think that's really one of the things that we have to give credit to Google. Also say that every social networking company in the world, LinkedIn and Facebook, also are all driven by graph databases. And then Amazon now also having a very strong component of graph, their product graph. Every time you do a search on Amazon, they're looking for similar members that have similar purchases in the past, and they're recommending things. So those similarity algorithms are core to everything. Anytime you sell products online now, if you can't do real-time recommendation
Mm.
in that 100 millisecond window, right, that you're not going to be as competitive as other companies in your sales. You need to have all that information about every one of your customers tied together, just like our clinical systems, so that you can make product recommendations.
Yeah. Well, and the sea of data is only going to be getting larger and larger, right? So
Right.
if you might be able to scale today on some other system, but just look another 1, 2 years down the road. I mean, data's coming in exponentially faster. So you
Yep,
got something that's
it
gonna
is.
it's gonna have to withstand the deluge of data coming.
Well, you and I have been doing IoT work now for what, 5 years together. We wasn't it
Hmm.
5 years ago, Justin, that we did our first IoT hack day, something like that.
Yeah, yeah. I think it was fall of 2015. Yeah, yeah, yeah. Yep, exactly. So yeah.
And what that shows you is that these sensors are getting lower cost every year. Microphones are getting higher quality.
Mm.
The deep field listening algorithms, so you can have a little microphone in one part of your house, and yet it can understand sounds across your whole house. That's just amazing technologies that are continuing to get better every year. And the ability for us to do sensors in the home, especially now, this is in the COVID times, right? We're in the middle of the COVID pandemic.
Hmm.
Wouldn't it be nice if we could stay connected to our seniors, care providers in their home without having to go into these centralized nursing homes where all the tragic contagion goes back and forth? Those are
Right.
all things that we're trying to do to make it easier for people to stay in their home. IoT is going to give us a lot more opportunity. Every time they turn on a switch, we can monitor that. Every time they get in out of bed, we can do bed sensor monitoring. Every time that they open their pill box, we can grab that information. So yes, there's going to be a lot more information about medical adherence in the home, and those are big things that are going to help us in the quality of care for our communities.
Yeah, yeah, excellent. Excellent. So I think I've read a couple of your blog posts, and I think you sort of call the enterprise knowledge graph EKGs.
Yes, right.
Right, right. So it's which I think is great. I love the terminology. I think you mentioned it's also sort of sensing sort of the lifeline or the heartbeat, I guess, right, in some way
Yeah,
of your
the
organization.
heartbeat of your organization. And when we went down this journey, there were a few things we were hoping for. We were hoping for better query performance. We were hoping for easier to tie this data together. But there were a lot of unexpected things that we didn't anticipate. And a lot of that has to do with the fact that these graph databases are amazing because there's virtually no penalty for doing joins, right? And when we first started doing this, remember, I'm an old relational guy, and we try to use a lot of our things. Well, let's just pretend every vertex is a table, and we'll put all the columns together there, and blah blah. And we made a lot of mistakes. What we found was that if we didn't model the world in reality, we call highly normalized,
Hmm.
where every real thing is its own vertex, then we couldn't reuse our models. They would break. They didn't really work correctly. Well, if we did our job correctly and we said everything in the real world should be a vertex, it turns out that everybody can share the same model. There are many ways to optimize performance, but there's only one way to model the truth of the world. And once you find that truth, then everybody can use it if there's no penalty for join.
Hmm.
And so we've been just absolutely stunned about how many business units, once we model the world right, can share the same model. They don't need to grab their own set of data and build their own mini data mart and hire their own analytics and have their own model, and their costs just go up and up and up because then they have to load the data and maintain the data and check the data quality. If we do that once for everybody, costs go down dramatically.
Wow.
So these scalable enterprise knowledge graphs have really started to change the entire cost models And cost models are really why AI is used in practice, because it's lower cost than doing these rules by hand. It's lower cost than the old manual way. And what we're finding is that the chargeback rates that our IT has for our business units is sometimes 1/10 of the old Hadoop days, where you have to have all the different representations based on your different query performance tools, the star schemas and the OLAP cubes and blah, blah, blah. Now, all of those reports can happen relatively quickly in that 10th of a second interval, with some exceptions.
Yeah.
But it's been revolutionary. And what it's going to happen is it's going to start to slowly have Darwin's law apply to relational. The costs are just too high. And so a lot of organizations that are still there are many organizations that are still building new relational systems, and they are going to be very high cost. As these scalable graphs come out, it's going to really change the dynamic, and it's going to do it by lower cost of operational systems.
What are some examples where you would not want to go graph, I guess? Do you have any of those offhand, or are you just kind of like graph all the time?
No.
No.
Graph
Yeah.
if you look at my history, I did a lot of work with this thing called NoSQL, right? But we wrote this book called Making Sense of NoSQL, my wife Anne and I. And it came up with 6 architectural patterns. Relational is the most common. 95% of transactions, at least in Minnesota, are still being done on relational. And then analytical, these OLAP cubes, where we have the pre-built aggregates, the star schemas, and huge fact tables. And then the 4 NoSQL, which are key value store, column family store, graph, and document. And what we find is that graph is really good for a lot of things, and it's really bad for certain things, like a blob store. If you have images, you're never going to want to store your images in a graph. Now, you store the URL to those images,
Sure,
so that you can integrate those things and do machine learning on them and tie the list of objects you extract from the images in. But in graph, RAM is precious, right? It's very precious, because if you have a big image sitting there in memory, it's going to swap out 10,000 links that you need to do your queries.
Mm-hmm.
So we really, really keep our RAM, try to load our graph directly in RAM. So any big blobs, any big documents are kind of forbidden in the graph storage. The other thing is documents, right? Documents are unique in that they have lots of words in them, and those words have meaning, and they have structure. You have words inside of titles. Those words are more important than words in other parts. And when you do a search, you look at relevancy. How relevant is this keyword to the whole thing? The structure of where the words in the document appear are so important. And so we don't actually use graphs for doing document ranking. Mm-hmm. We only use it for things that really are about fast queries and interactive things and analytics. And we also use it to power our machine learning. We do a quick extract, get the data into our models, do the training, find out the insights, and pour that data back into the knowledge graph. So it has really become a central hub for a lot of these things, but there's a lot of use cases that are forbidden. And some of the analytical things where you pre-calculated sums and totals, once again, it's not going to replace a Cognos or an OLAP cube or things like that. Those have other use cases that those are custom to.
Excellent. Yeah, good. Yeah, always everyone sort of wants to hop on the new hotness, right? The new bandwagon, and I feel that way in some ways with blockchain. I'm by no means a blockchain expert, but over the past couple of years, blockchain's been used for everything, and it's like, no, you don't understand. It's actually not meant to store a whole bunch of data in the blocks.
That's right. That is a really good example. There is an expression in the graph community called graphs are everywhere. So if you look at the real world, there's a lot of things, and those things have relationships. So anytime people come to us and say, gee, we think we could model this in graph, that's great. Blockchain is really odd because it got so much press. But if you actually look at how to qualify a business project for blockchain, you say, if you have groups of people that need to work together, and if they won't trust their own internal computer systems, and if they need a distributed ledger, and if they want that auditability, and if there's about 7 different ands, right, only then would you ever pick blockchain. So there's so funny stories about business units that come into the ATC and say, gee, we have this problem, and we thought blockchain would be really useful. No, not even close. But graph is often a good fit for those things.
Sure.
Blockchain is a really good example story of a very hot technology that unfortunately had a very, very narrow set of use cases. Less than 1% of the use cases that come across my desk are blockchain related. And it only has to do right now with when we're trying to build consensus about transactions between organizations. And
Sure.
those organizations also have to agree on the standards on how to represent those things. And that standardization process only often takes 3, 4, 5 years sometimes. So the ROI for blockchain projects still may be there, but none of our business units want to invest in something where they don't know if they can see the result until 5 years. That's
Yeah.
probably not a great thing. So I'd say it is still a great technology for certain things, but we have to narrow down our use cases. So blockchain is a good extreme. Graph is the other end of the spectrum where there are just so many projects that could be using graph for knowledge management today that aren't. But within the constraints, there's certain things we don't use.
So is that part of your role, I guess, is educating people on
Absolutely.
graph or
Yep.
or just all sorts of technologies?
Yeah, all sorts of technologies is
Okay.
really so I consider myself a solution architect. A solution architect is a role where the business unit comes to a solution architect and says, we have these problems and we'd like to work with you to figure out what is a good match. And so we go through and we gather the requirements. There's always many requirements that come in, but say we have 1,000 requirements come in, we might distill it down to 20 what are called architecturally significant requirements. For example, if somebody says, well, the system has to be up 5 nines. Well, then a single relational database is never going to work because you have to have replication and you have to be able to upgrade the software without ever shutting it down. You have to have rolling upgrades in the cluster. So we know that if you have super high availability, that all these NoSQL technologies are going to be a much better match. So we go through and look for those requirements and we match it to the right, not just database and data structure, but the entire stack of tools these days.
Gotcha. I think you mentioned you've been doing a lot of stuff with NLP, I guess. Is that one of your sort of your current passions?
Right, it is. And I don't know if you've played with any of these tools, Justin, lately that are all built around the BERT architecture, the transformer based systems. But it is just amazing to see, just in the last 6 months, the amount of development that's happening. I think if you ask me about, where is Skynet going to evolve from today, it's going to be built around a lot of the tools that people are trying to do to understand language. And many of the tools that we have developed in NLP, in A, are now spreading across the industry in other areas. One of my best examples is these things called embeddings, word embeddings, right? So there's some fantastic demonstrations out there now where you take all of Wikipedia, you load it into an AI model. So it's unsupervised learning. You don't have to have a training set with this is this word labeled and this type and stuff. You just load the things in and they start to, quote, understand the meaning of these concepts. And you can do things like, is a baby older than a grandparent? And they will answer it, right? They're starting to have understanding of all these concepts and how they're related to each other. Have you played with the Talk to Transformer system yet,
I
Justin?
did. I did. Yeah. That was fascinating. And the thing that's neat is you don't know what you're going to get. It's different every time, right? So I put in something about, will the Internet of Things change the world? And then it just rambled on, right? It basically had a full sort of like paragraph with regards to what it did. And I'm like, okay, well, I mean, it was plausible. I was
Yeah.
pulling together a bunch of jargon, but it was definitely on track. And then I
Yes.
I clicked the generate again, and it generated something that was like equally well. So I found that pretty neat.
Yeah. So that's a really good example of a very large corpus of text fed into this very large system, GPT-2, done by OpenAI, and it's really starting to understand things. And what you found is that if you type in something in a totally different domain, so you typed in something about rock music, it will write you an essay about rock music. If you type it about kids' fairy tales, it'll write you a paragraph about kids. So it knows about all these related concepts. And if you put in the name of a rock band, it's going to know similar bands that were also in rock,
Hmm.
right? So that's just really freaky to me about how these neural networks that are behind this are getting close to understanding. Now, the sad thing about that is that they've been using a lot of brute force and massive tens of billions of parameters in their neural network models. I always remember the human brain is about 82 billion neurons, right? 10 billion is getting in the same order of magnitude, but it takes tens of thousands of dollars to train those models,
Right.
which means that all of the other researchers around the world are falling out of the race, right? It's just Google and Facebook and Amazon and a few other organizations that can afford to blow $100,000 to build a model are now doing this work. But now we have another innovative group of people that are saying, well, you guys are very wasteful. You're using brute force. If you're really clever, we can prune these networks and we can do all these other things to make it much smaller and yet still get close to the same results. And what you see is that there's just tons of innovation happening. So it's not just brute force and pruning. And a lot of the papers that are coming out about making your networks much smaller and yet still precise, I think are great areas for research. And every time some of those new papers come out, I'm very interested to see whether we can, actually train a good natural language system for $10,000, not $100,000.
Right. I mean, I've always thought that brute force at some point falls down, right? I mean, I
Right.
don't think it's the answer. It's the end all be all.
That's right. Yeah, you can have brute force in the size of data, the number of GPUs you have, the size of your network, the number of layers, the number of parameters, all sorts of ways to do brute force. And sometimes they have to scale up together. And in general, they are getting better results. But the question is, are they building models that you can actually deploy? Right? Because you can't take 100 billion parameter model and deploy it on a cell phone anymore, right?
Right.
Well, you can do inferences on this huge data center. So we do need to have small, light networks. And you know what it says to me, Justin, is that the human brain is still just an absolutely amazing thing. That every night that we go to sleep, and the theory is that we learn a lot during the day, and at night when we sleep, we prune our neural networks so that
Interesting.
they're more efficient. Now, once again, that's a theory.
Theory.
It's
Yeah.
we don't really understand it. But what it shows you is that we're just at the beginning to understand the process of learning and training these artificial neural networks. And there's just such a wonderful opportunity. I almost wish I was a grad student today so I could spend a lot of time just studying these algorithms and make some innovative contributions. Because a lot of the contributions that are coming in aren't just the PhD researchers deep within DeepMind at Google. They're coming from Canada. A lot of the people that Geoffrey Hinton trained, a lot of the places that are really still looking at it in an innovative way. So I think there's a great opportunity for young engineers to continue to try to understand the dynamics of these things and to be innovative. I can't wait to see some of the models. A lot of people are saying that these models, as they get better and bigger, we are going to see an inflection point where they really start to understand, and we can ask them questions in a chatbot, and they are going to give us answers that are reasonable.
The Turing test.
Yes, the Turing test. I think we're 10 years away from being able to have these natural language processing models pass the Turing test. But it's going to be a combination of creativity and symbolic reasoning and inference and these deep neural networks. It's not just going to be flat deep neural networks. Other technologies are going to come into play too.
Sure. Fascinating. You talked a little bit about sort of being a grad student these days, I guess, and I know one of the things that you are very passionate about, and you've worked very hard here in the community here, is helping youngsters learn new technology, whether it be IoT and Arduinos, programming of all various sorts and stuff like that. And I know one of your current passions is this AI racing league. Could you elaborate a little bit about?
Yeah, absolutely. Well, you've been involved in that too. I think you were one of the first people to print a 3D chassis for me, Justin. So I
I
still
did.
still owe you a favor for printing that first chassis for me. Yeah, absolutely. So one of the interesting things about this AI racing league is part of its piggybacking what's called the donkey car movement. The donkey car was a car that was created by a bunch of researchers out in the Bay Area. And they asked a simple question: what's the cheapest car that we could build using an RC car and a Raspberry Pi that could take the images from a camera and drive around a track? And they started that almost 4 years ago, and it was very primitive. But it's interesting how many people were interested in that same question. So they had a small group of 4 people get together, and the next month they got together, they had 8, and then that doubled to 16. And just recently I heard that they had a group of 250 people come to a single meetup with cars,
Wow.
all trying to race around these tracks. So it's really taken off quite a bit, and it's now a worldwide movement. I think there's 85 leagues around the world in almost every country setting up AI racing tournaments. What's interesting about it is that it's kind of fun. right? AI is, for a lot of people, it's scary, right? When you think of AI, you think of the Terminator, the movie, the horror and the gore and the science fiction movies that prey on our uncertain views of the future, what
Mhm.
is unknown. But in reality, AI can be fun and it can be very beneficial. And within Optum, I have product managers I work with. And I had a lot of product managers who said, well, I've heard you're doing work in AI. What exactly is that?
Mm.
And is there any way I can learn more? And so we've decided to let all of our product managers go through this AI racing league so that they can just have a feeling of what it is to drive a car around, gather some data, run it through a GPU, build a model, take that model, stick it on your car, and hit the auto drive. And once they do go through that life cycle, it becomes a lot less intimidating. It becomes something they understand all the pieces and the workflows. And those are the same things that we're trying to do to our high schools and the teachers in our high schools that are trying to set these things up. And it goes on to not just AI, but it goes to a broader thing of data literacy, right?
Mm.
If you ask employers today what are the most important skills, data literacy is something that always comes up. They need people that can load data into spreadsheets and do analysis and create plots and charts and do trends. Every part of a company, marketing division, research and development, their sales, sales forecasting, all of these things are now data driven. And yet we graduate students in the state of Minnesota where they can graduate from a high school and never have to use a single spreadsheet.
Hmm.
Right? It's not part of our graduation standards. So the only people that are really doing this are teachers that take it upon themselves to develop this curriculum. And that's a huge amount of work, and they often don't have the support, the training, the background to do this. So if we care about our future jobs in Minnesota, we have to understand that these teachers aren't going to magically understand data science and data literacy and just transmit it. We, as engineers in our community, need to be part of that role, and we need to volunteer in these schools, help the teachers come up to speed, help the students do it. John Herkey has been doing some amazing stuff, one of the guys that you and I know in the
Yep.
Futurist Academy, and we all need to really take a more active role. In the Bay Area, it's different because everybody works in this every day. And so their kids are interested in it, and the teachers then get influence. Here, we have to work a little harder. We have great analytics people. We have a culture of retail here in Minnesota. We have Best Buy, we have Target. A lot of great SaaS developers came out of those things to do predictive modeling for inventory management and control and things. But are we really making this next leap to machine learning and AI? I'm worried. And I think we need to take a much more active role in helping our community come up to speed. And I think the AI Racing League is one vehicle for doing that. And there are other vehicles too that we can work on together. Justin, you've also done a lot of work with setting up things like hackathons.
Hmm.
And I want to acknowledge all the work that you've done setting those up to get people educated, because that's really about community training, isn't it?
Yeah, yeah, it is. It is. It's about getting people's, well, there's a number of different aspects to it. It's just, it's getting dirty, right? So, hey, I have this idea. Let's just dive in. It's about working together on a team, right? So
Right?
it's not just a one person show. We always have teams. Teams have to be two or more.
Yep.
Sometimes they grow up to be 8 or so. And then, there's the whole aspect of having a deadline.
Yep.
I like to tell people I joke around because my basement is littered with tons of projects. Since I didn't
Yeah,
have a
me too.
deadline, they just kind of
Yep.
ended. And then the last part is just having fun, right? So yeah, it's just sort of enjoying the day and sort of building stuff together. And so yeah, we've had a lot of fun focused on doing IoT hackathons, and I think as we sort of evolve the group and evolve what we're doing, I see us doing a lot more in sort of the AI space as well.
Yeah.
So
The evolution of these devices, from Arduinos to Raspberry Pis, the NVIDIA Nanos that we have 128 CUDA cores directly on a $99 edge device. And I think right now you can get something that has almost 10 times that power for about twice as much now, for about $200. Those devices are just going to continue. And I think our hackathons, we need to have teams that are pre-trained in how to use the NVIDIA Nano and come in with their data or show them how to build a machine learning model. And the best thing is cameras, right? There's so many image recognition where you can have people walk by a camera and count the number of faces that come out. And those are just out of the box computer vision algorithms.
they
Uh,
are.
So we want to get more of those into our IoT devices.
Yeah, yeah, and it's almost magical when people see it the first time. They're like, "Wow, it can really pick that out," you know. And
Right.
it's like, "Wow, yeah, yes, actually, we just sort of, I guess, collectively have gotten really good at getting a lot of images of cats and dogs, you know,
Yeah.
and of human faces. I mean, it's amazing. Google Photos, you know, I'll take a picture
Yeah.
of one of my kids, and it'll realize that it's him. You
Yeah.
know, of course, the kid's face has changed over time, but it's amazing how accurate it is.
Yeah. What's amazing about Google Photos is every month they add new algorithms to understanding how to label photos. Recently, I typed in sunset. I was looking for a sunset picture for a background, and I found not just sunset, but other images that were also very relaxing. So I just typed in the word relaxing.
Uh,
So I typed in an emotion into Google Photos, and it could associate emotion with those pictures. So
wow.
that shows you that they're really every month they're getting better and better. If people haven't played with Google Photos, it is just freaky to see the quality of the labeling that they have for those images and how they're doing the same embedding for pictures that we're trying to do for our patients, right? Break it down into a set of vectors and compare those in distance for similarity. Every word now can be associated with a set of concepts that when you type in, and you can associate those concepts with the dimension of those pictures. So it's really cool to see.
Yeah, yeah. Well, some closing thoughts, I guess, you know, from you. You touched a little bit on the AI Racing League. Obviously, you know, if any people that are interested in that, I'll make sure to include links and stuff like that to the liner notes here on the podcast. But if I'm new and I say I'm a professional, I'm getting into AI. You talked a little bit about data literacy and storytelling. What's some advice, I guess, for people that are just sort of getting into this field?
Well, I think AI is really being dominated by machine learning, and machine learning is being driven by data. So the first thing I would make sure people know is that you have to have a data strategy. Knowledge graph is one part of that data strategy. But there's this thing we call the AI flywheel, which is the more data you have, the better models you can create, the better models you have, the more customers you can help, and the more customers you get, the more data you have. So those are incredible cycles, and you don't have to start with a huge amount of data. You can start small and then grow that. Our team does have access to a lot of data, but I still think there's huge innovation that can be done, and we're starting to see a lot of companies still form. So I'd say if you're going to do a startup company, have a data strategy and then use AI and build on top of that data strategy. I think the biggest thing I'm really worried about is not just can we explain this to our fellow engineers, but can we explain this to the non technical decision makers in our organization? We have a joke we call the HIPPO joke. HIPPO is HIPPO, stands for highest paid person's opinion. So that's often how organizations make technology decisions is they ask the CEO and they say, what do you think the impact will be of AI? And the CEO may not be an expert on AI and what's happening in the thing. So I think a lot of that we have to do is we have to arm our technologists with how to help outbuild AI strategies into our company strategies. And that means that it's not just how it works, but we have to be really good at storytelling. All of our decision makers need to hear these stories over and over, and we need to tie those stories together with really good, compelling demonstrations of how this works to help them remember the stories when they're in the boardroom and being quizzed. Well, what's going to be the impact of AI on our product line? Those things are things that I hope our Minnesota companies really embrace, getting AI people to influence the decision makers if they can't even be on the boards, which would be ideal, I think, but it's not going to happen overnight.
Sure, sure. Well, excellent, excellent. Thank you so much for all this, Dan. Now, I don't know, do you have anything else, I guess, that you'd like to add? I mean, we covered a fair amount of ground here today, and we're about 50 minutes or so into the conversation. But yeah, I'd like to open it up and see if there's anything else you wanted to talk about.
I think the biggest thing I want to work on in our community in the Twin Cities is getting more people involved in the AI community. And if the AI Racing League is one way to do that, if attending meetups, now virtual meetups in with data science, if volunteering with building community projects where we can help those things out, those are all things that I hope that we can work on together. And Justin, you've been one of the best leaders we've had. So I hope that you can continue your success in the applied AI group that you've had in the IoT space. And if there's anything I can do, I'm definitely like to help you do that in the future.
Well, thank you, Dan. Yeah, I appreciate it. What's always driven me with a lot of these new technologies is just my own personal passion, right? So if you're not doing it for your own personal reason, like you have a good drive for it, it'll kind of fall down. And so for me, I see so much promise here with regards to artificial intelligence across. I mean, it's just endless, right? How we can apply this to so many different market segments to solve some totally crazy problems, and honestly, I've been also reading a fair amount about how AI is going to change just the future of work for all of us,
Right.
right? And so, there's a lot of things that AI is going to replace, but you sort of touched on that storytelling piece to it, right? And even you mentioned a little bit about a physician working in collaboration with the artificial intelligence.
Right.
And I think we're going to have to approach, I guess, my kids as they turn into professionals, they're still 15 years away from that, but as they come out of college and like whatnot, it's going to be a completely different landscape, and AI is going to have had a huge impact on that. And I'm not scared
Yeah.
about it. I just want to understand it and have them understand it, and have all of us, I guess, as humans, understand how we can sort of harness this power and apply the best use of it going forward.
Right. They say that AI is the 26th general purpose technology that has been known to humanity. The 25 before have things like the fire and wheel and electricity and stuff. And AI is the 26th. It's a very general purpose technology. It's going to touch not just one or two industries, but everything. Everything in our lives will be touched by AI. And so your leadership in this area, I think, is going to be helping us figure out where we can apply these things to companies in the Twin Cities and help us be productive and part of an ongoing thing. What I would hate to have happen is that all AI advancement is going to be happening just in the Bay Area at a small list of companies. That would be a tragedy, right?
Yes.
Or in Canada, where they have really good research. I'd love to see this also be part of our Minnesota landscape and make sure that all of our community works together to build companies that do this. And I'm looking forward to continue to work with you on this applied AI podcast and other things. So let me know if I can help in any way.
Excellent. Well, thanks, Dan. Amen to all of that. Let's keep Minnesota strong in this technologies. I think we'll continue to be doing this podcast and continue to have great influencers like yourself and others in our awesome community here for future episodes. So
Right.
Thank you again. I appreciate it, Dan.
Thanks so much. You take care.
You too.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.